this one. Do you guys remember we called these, and I don't have to do every piece of that, but we call this the dummy vector field. You can have multiple of them. What was the property of this dummy vector field? The property of the dummy vector field is that the curl of F is going to be in the Z direction is 1. The curl of that F, see, partial of that with respect to X is 1 minus partial of that with respect to Y is 0. So it's going to be 1. Let me write it down. I see. This is going to be 1. That's the nice property of that. So what happens is that, do you see it's telling you about all this nice looking area. And so the nice looking area, the boundary is parameterized. The boundary of this area is parameterized. And it turns out if I want to find this area, it's kind of a rough thing to do. The reason you learn this is because in the industry, this formula of a dummy vector field and then computing the line integral is the way that they figure out the areas. And so that's why you're learning it. That's like the actual thing when they measure area, they go around the boundary of that area. And then with different devices, they can, and usually it's not that specific vector field, it's another vector field that they use. But what they do is using those vector fields, they figure out the area. Yes, there's the device that you use on a map to find the area. There's a device that civil engineers use in the field. They go around the field and they figure out the area. There is a computer scientist, when they're making video games, they use the same concept. So it's just like they're so broad, and it's a little thing that is there, basically. So there's a lot of places that this happens, actually. And so how do we go about this? All these steps that are said in here is for you to understand what's happening. This is the parameterization. If I find R of 0, it's going to be 0. If I find R of 0.25, if you plug in, you get a point that is about, I think, it's going to be a point right here. And if you find the other one, a point out here, this is R of 0.25, R of 0.5. So technically, you can look at that and figure out that the direction is counterclockwise, and so it's a good direction for the Green's theorem. So the problem is kind of taking you over it. I did. This should be A, B, C, D, and then the next step is to compute the contour line integral of the FDR on this one. Why? Because this is going to give you the area, and that's the story, basically. So I'm going to do the contour line integral, and how do I do the contour line integral? I have to find the R is given. Find the R prime of T. So I did one problem that was easier to use the right-hand side of the Green's theorem. This is the problem that you have to use the left-hand side of the Green's theorem. to find the area. If the computation on the area is easier, you use that to replace the line integral. If the line integral is the only one that can be done with this situation, you use the line integral to replace the area. That's all it is to it. So R prime of t is going to be what? Derivative of that, which is, it's going to be a long one, but let's do very quick product thing. So I'm going to get negative 2t times multiply these together. It's going to be t squared minus 3t plus 2. So, and this part is just going to be t times t squared minus 1. So I have, let me do it all the way, negative 223t plus 6t squared plus 2t minus 2t. And so I take the derivative of that and I get minus 6t to the power 2 plus 12t minus 2. And then the second part, this is just going to be t3 minus t. So it's 3t squared minus t. Okay. So I did that. Then I do the next step is to use f at r of t. F at r of t is just 0 and x, which is negative 2t to the third plus 6t squared plus 2t. Now dot them together, and you get negative 2t to the third plus 6t squared plus 2t times 3t squared minus 1. And it goes from 0 to 1. dt, and the answer is going to be 1/10. Now, very last part is asking you to find part D. This was part B. Part C is asking you to find curl z direction of f dA, which is going to be the double integral of 1 dA, which is going to be just area of D. The last part, part D, is saying, so what is area of D? Area of D, according to Green's theorem, is equal to 1/10. That's all. So you found the area of D in that manner. Are you guys okay still?